Welcome to today's webinar with the title Coverlay, More Than a Flexible Solder Mask Substitute. I am Andreas Schilp, your host of today's Würth Elektronik Circuit Board Technology webinar, and I would like to welcome you. The speaker of today's webinar is Verena Laukemann from our Technical Project Management at Würth Elektronik Circuit Board Technology. Welcome, Verena. And now I wish you lots of fun and new information.
Also from my side, hello and welcome to today's webinar. Before we start, I'd like to introduce myself briefly. My name is Verena Laukemann and I have been working at Würth Elektronics since 2012. For the last 6 years, I have been mainly involved with rigid flex applications, and for the last 4 years, I have been working in technical project management. There we deal with special customer requirements and their implementation in our production. If you have any questions about rigid flex printed circuit boards, or of course about Coverlay as a substitute for solder mask, please feel free to contact me and my colleagues. You will find the contact details in the QR code. To begin, we look at the properties of Coverlay and insulation foil. Then we will learn which design rules have to be observed and which possibilities are given for cost optimization. An application example illustrates the successful use of Coverlay as an insulation foil. Finally, we will summarize what we have learned in a short overview. At the beginning, I have a question for all of you. I want to know, for what purpose do you use insulation films so far?
Yes, so I will start the poll. You should see now a blue screen where you have different options to choose, and you can choose more than one of them. So please make your choice now. So there are already some answers here. We are around about 30% participation, 40%, 50, 60%. Okay, so that's okay. I will wait another few seconds. Then I will close the poll and will show the result. Wow, we have 100%. That's the first time we got 100%. Great. So this is the result. 86% using Coverlay for electrical isolation. Mechanical protection is 14%, around about 30% for thermal protection, 14% others. And no one is not using Coverlay for isolation foil, so that's also very interesting. So thanks a lot for your participation.
Thank you for that. That shows that most of you use the insulation foil for electrical issues. I'm very happy that no one is not using insulation foil at the moment. And I will now show you a good alternative to your insulation foil that you use up to now. So we will start with Coverlay as an introduction. Most of you are probably familiar with Coverlay as a cover foil for rigid flex printed circuit boards. But what exactly is Coverlay, or rather this Coverlay foil? Coverlay is a composite material, means it consists of 2 or more materials. In this case, it is polyimide and adhesive. Polyimide is already known from rigid flex production. It is a flexible base material, which is typically 50 microns thick. In the case of the cover layer, the polyimide is usually somewhat thinner and is approximately 25 microns thick. A higher polyimide content in the cover layer is of course possible. We can do 25, 50, 75 or 100 microns. The second substance in this composite material is an adhesive. Often we use acrylic or epoxy adhesive with 25 or 50 microns of thickness. Thicker layers are also conceivable here and even make sense if the copper thickness is very high. For example, if you have more than 40 microns of copper on the outer layer, then it makes sense to use 50 microns of adhesive or even more. Coverlay is typically used to protect copper surfaces and signals in the flex area. Another application, although less common, is the spanning of holes as an alternative to the classic filling process with filling paste. In summary, Coverlay is a versatile material that is frequently used in the PCB technology. The reason for the material's use is its very good properties. In addition to the UL listing according to V0, Coverlay also has good thermal properties. The thermal conductivity indicates how well a material conducts heat or how suitable it is for thermal insulation. The lower the thermal conductivity value, the better the thermal insulation. Air, for example, has a conductivity of 0.026. So Coverlay is a worse insulating material than air. Anyway, this value is quite low and therefore material is a good insulator. And we can see, but on the other hand, the thickness is very thin and we have a big area which is covered with Coverlay, and therefore it's also good for heat transformation or for heat transport. The material also has a very good dielectric strength with 4 kilovolt per mil. The values refer to the thickness of the polyimide without the adhesive, what means only the 50 microns of polyimide have a dielectric strength of more than 8 kilovolts. The adhesive thickness can be neglected in the calculation. Another property that I personally appreciate about Coverlay is its low outgassing. This allows to use the Coverlay in vacuum environments, and therefore it is an ideal complement to conventional solder resist. Now we have already learned a lot about the material, but we still do not understand how it is processed. Coverlay is purchased from Würth Elektronik in production panel format. Since only some areas of the production panel are to be covered with Coverlay, the material is cut to size using a cutting plotter or a laser. The picture shows the process using a cutting plotter, which is our standard process. The Coverlay lies on a vacuum table and is cut out with a knife attached to the cutting head. The excess material around the blanks is simply peeled off. The individual parts remain. The blanks are now registered to the layout using a mask. You can see the mask in the picture, and we have here two cutouts. The upper area shows the empty cutout, which exposes the area which shall be covered. In the lower area, the Coverlay has already been inserted. To prevent slippage during the subsequent processes, the Coverlay is fixed to the printed circuit board by hand. To do this, the corner of the Coverlay parts are tacked to the circuit board with a soldering iron. This fixation is sufficient for the transport to the next step, the pressing. The pressing is carried out by a so-called vacuum laminator. As the name already suggests, the Coverlay is laminated to the PCB under vacuum using pressure and temperature. The result is a firm bond, such as you may already know from one or the other printed circuit board. As a cover film, Coverlay has long become a standard. The use as insulation foil, on the other hand, is less common. although the requirements for an insulation foil can be met by the properties of Coverlay. Just like Coverlay foil, insulation foils are mostly used to protect the printed circuit boards. The typical applications include electrical or even thermal insulation against the housing. Due to the comparatively low thermal resistance of Coverlay, it can be used for heat transport in heatsink applications. Another area of the application is mechanical protection against vibration or shock or abrasion. Especially in narrow housings, a film is very suitable due to its low thickness. As you remember, the Coverlay is only 15 microns thick. Insulation foils are often used in areas where high currents are transported, such as control units, bus bars, or high current applications. There, their task is the electrical insulation, but also the transport of heat to heatsink components. Another area of application are applications with small space, such as you know it from sensor technologies. Of course, there are numerous other areas for application that are not listed here. Now the question arises, how can these areas of applications be agreed with Coverlay as insulation film? As we have already seen, Coverlay is characterized by its versatile properties. First of all, an insulation film should insulate against other electrical potentials. With its dielectric strength of 4 kV per mil, Coverlay meets this requirement very well. In addition, the good thermal conductivity allows heat transfer to the heatsink. The heat dissipation is supported by the low overall thickness of 50 microns. It also allows the use in tight spaces. Another advantage is the low outgassing compared to the solder resist, which makes the material suitable for vacuum applications. The above advantages show that Coverlay is very well suited as an insulation film. Now, before you switch your designs to Coverlay, let's look at the most important design rules. In the design, in addition to the size of the clippings, the shape of the Coverlay parts must first be taken into account. As we have seen, Coverlay is registered to the layout manually, so the Coverlay parts have to be laid by hand and therefore have physical limits. The size of the Coverlay parts must be at least 10 × 15 millimeter so that it can be handled in the process. In the example on the right side, there are numerous Coverlay parts installed, and you see that one of them is only a few millimeters in size. The small size increases the process time when registering the Coverlay and therefore increases the price of the PCB. In order to be able to cover small areas with Coverlay anyway, the individual Coverlay parts should be connected to each other. I have here an example for you to make sure that you understand what I mean. In the example, you can see several flex areas that should be covered with Coverlay. Now there are different possibilities. It is conceivable to lay the Coverlay as a single part. In the case of this shown 3-up delivery panel, 3 individual parts are thus laid. Alternatively, the 3 individual parts can be combined to form a larger part. This increases the size of the Coverlay part to the required minimum dimensions and at the same time reduces the price because we have less parts and less work which have to be done by hand. In the example on the right side, we have also connected the Coverlay parts so that we have less parts for production. In addition to the size, there are a few tips to consider for the shape in order to optimally support the adhesion of the cover layer. In general, sharp corners should be avoided. In the picture, sharp corners have been installed at the transition between the round pads and the SMD pads. In addition, the radii used are very small, which makes it difficult to cut and to register to the laying mask. Moreover, it can break because of small webs. It is better if the corners are replaced by radii, as shown in the picture. The radii should be greater or equal to 2 mm so that there are no tears when cutting. Another important aspect is the size of the lens. The pads in the picture sits very close to the PCB outline, resulting in narrow overlay lens. Although the coverlay is usually drawn beyond the contour, only a few millimeters remain as coverlay ridges. In some cases, the coverlay may not extend to the edge because, for example, edge metallization is planned. When designing, it is better to consider the outline as an outline. In this case, the clipping should be done in radii, as shown on the left below. If the coverlay is allowed to extend beyond the contour, the clipping can also run in the straight line up to the routing, as shown in the upper area. To avoid small individual webs, the webs of 3 pads were connected as shown in the example. This makes the manufacturing process much easier and is therefore strongly recommended. The next big point is the clearance. The IPC makes a recommendation for the design of the clearances. In the IPC 2223, there are several values which are shown here, and there are further recommendations for flexible single-sided PCBs. For PCBs with plated vias and rigid parts, means for rigid, flexible, and multi-layer PCBs, the clearance should be at least 0.25 mm, larger than the solder area. For webs between the openings, a minimum of 0.25 mm is also recommended. In practice, it has shown that both values are borderline in the processing, and therefore Würth Elektronik recommends to use some larger values. As already mentioned, the parts should be as big as possible. The absolute minimum dimension is 10 × 15 mm, so that the coverlay can safely be registered in our process. The clearance around the drills and the SMD pads can be implemented either individually, as shown under A, or in a window, as shown under B. The choice of which variant is used depends on the distance between the pads. Depends on the distance of the pads. To avoid free solder path flow between the pads in option B, it's possible to use a frame of solder mask around the pads, as you can see in symbol C. The clearance of the solder mask are a lot smaller than the clearances for coverlay because of the photo imaging process. Both the circumferential clearance and the web width must be at least 0.5 mm. This is on the one hand due to the manual registration process, and on the other hand to the adhesive flow that occurs during pressing. If the webs are too small, they may also tear off during the process. In order to keep the contact surface free of solder mask and adhesive, we recommend mainly the above mentioned clearance of 0.5 mm all around. As a result, the distance between the SMD pads must be at least 1.5 mm for option A. For option B, on the other hand, the minimum distance is not based on the clearance, but on the copper clearance. On the outer layer, a distance of 100 microns between the copper areas is possible. These and more recommendations can be seen in our design rules for insulation foil. You can see the link here, and you will also receive the presentation afterwards so that you can have a look at the design rules. So larger extensions generally reduce the manual effort and thus the process time. So it makes absolutely sense to use our recommendations. So now we will have a look at the price and its optimization. On the left side, we look at the cost drivers. On the right side, the optimization options. As already mentioned, small overlay particles complicate the process. Moreover, a large number of individual parts increases the process time and also the costs significantly. In addition to a longer process time, small extensions lead to more adhesive flow and thus to more damaged goods during production. If the cutouts are too small or the clearances are too small, the coverlay has to be cut by laser, which is more expensive and takes a longer time. In general, please think of less is more. This means that a few coverlay parts are possible. If only a few coverlay parts are possible, then it should be used like this. So please try to combine the single parts so that you have only one or two coverlay parts. A good example is shown in the picture below. Instead of applying one coverlay part per PCB, only one large piece is used, which is connected via the delivery panel. Another way of optimizing costs is based on the cutouts. Very small cutouts have to be cut by laser and increase the process time and the costs as mentioned. Both can be avoided by using sufficiently large clearances and of course less coverlay parts. Last but not least, delivery panel is very important. It decides how many printed circuit boards are produced per production panel and therefore has the greatest leverage for cost optimization. In the picture, you can see the CIF connector of another PCB, which was placed rotated by 180 degrees to the upper row. The rotation allows the space between the flex area to be used as well. You can see it in the dark gray, which shows the flex mask on the flex area. This allows a much higher utilization of the production panel and, of course, less costs for you as a customer. So if you need help to do a nested panel, please contact us and we can make a good recommendation. Perhaps you can already think of one or two possibilities in relation to your applications where you can use Coverlay as insulation foil. And that brings us to the next short survey.
Okay, so this time we cannot use the system to do this poll. This kind of poll is an open question, and we ask you to give us your ideas over the question box. And if you have any ideas for applications using Coverlay as isolation foil, please write this in the question field and send it to us, and I will read your tips and ideas via voice. So we will have some seconds to wait for your ideas. And please use the questions field. Actually, no idea till now. Oh, okay. So there's one answer or question. Anti-high voltage. So I think this is an application where you want to try to provide damage to sensing high voltage signals. Yes, of course. Another idea is isolation temperature, as we have already heard from Verena. So these are the most typical applications. Any crazy other idea? So of course you can also write it after the poll. If you have any more ideas, please feel free to write this maybe via email or in the questions field during the webinar. So we would also like to discuss your ideas with you. So please feel free to come with the questions. So there's another idea, good flexibility, mechanical strength. Yes, so to protect the surface against mechanical impact. That's a good idea to use that. Okay, thanks a lot for your ideas and your collaboration. I will hand back to Verena again to continue the presentation.
So the mechanical isolation or insulation is an important topic, and this was also important for one of our customers, and we will now have a look at its application example. Insulation foils are often used in areas where high currents cause heat of on top of the circuit board. This also is the case in our application. Here we have a control device in a marine engine. We had here temperatures of 105 degrees Celsius, which were generated by power elements on the printed circuit board. The heat is to be dissipated via a housing part made of aluminium, which you can see on the right picture. For this purpose, the circuit board is screwed to the housing. At the same time, the exposed copper areas must be electrically insulated from the housing. Also, no connection may be created by solder flowing. Vias must be filled so that no solder paste will flow on the housing. Vibrations and shock can also happen in this area, and it's not allowed that they create damage, because this damage will create an electrical connection between the PCB and the housing. So therefore, the insulation must have a high abrasion resistance and must not be damaged by vibrations. To meet the requirements, an HDI structure with microwires and buried wires was used to eliminate the plated through holes. To do an isolation against the housing, the customer tried to use an FR4 pre-preg, but all this was not very successful and not satisfying, and therefore Coverlay was tested as an alternative. In the course of the testing series, it becomes apparent that Coverlay meets the requirements. The low thickness enables good transfer to the heat, to the housing, so that the heat can flow away. Moreover, the dielectric strength was a very good addition. The vias were spent by the Coverlay so that the HDI build-up and the filling process were eliminated, and this also saves costs. Of course, also the manufacturing effort was a bit smaller, and therefore the lead times could be reduced. Resistance to vibration and shock is also provided to be very good. Initial field tests showed that neither vibration nor friction damages the Coverlay. So all in all, the Coverlay fulfills all the above required requirements of the customer, and it also optimizes the costs of the overall system. This PCB is now running since 15 years at Würth Elektronik and at the customer, and both sides are very happy with this solution with Coverlay as insulation foil. So this already brings us to the summary. The example has once again shown very well that Coverlay is suitable for both electrical and mechanical protection against abrasion. In order to make the most of the advantages of Coverlay, we looked at the design rules in terms of shapes and clearances. A look at the design rules at the beginning of a design is highly recommended. To optimize the cost, always remember less is more. The fewer Coverlay parts are needed, the cheaper the overall system will be. If possible, individual parts should be combined into larger parts, for example, via the delivery panel frame. Finally, we looked at an application example from the field of engine control. The Coverlay here meets all the requirements that were placed on the insulation foil. In addition to the engine control, there are numerous other applications, for example, vacuum applications and a lot more. So perhaps you already have an application in mind in your field. If you have any questions about these topics, please feel free to contact me. I'm looking forward to hear from you. Until then, I would like to thank you for your attention and hand over to Andreas.